Good morning, everyone. Interested to see so many people after yesterday evening. I expected 10. Anyways, welcome to Kubernetes on AWS Gone Wild. I'm Chris, pretty much teacher doing this as well. So pretty much this talk is going to be around about, I hope I have time for 9 war stories, what we experienced when deploying Kubernetes on AWS in the past. Specifically one, let's say, larger corporation. So be aware those are our learnings. We faced those issues, might be different for you, but it's things to consider, also different approaches how to do stuff on AWS. Yeah, basically, is anyone already using Kubernetes? A few doing this on AWS? The same. Was it easy? A little. So basically 3 main topics. I tried to split this up into, first of all, how should you think about designing your clusters? Just basic things to consider. Then how to install stuff on AWS. Different ways how to install stuff on AWS. What are the pros and cons? And then actually operating stuff on AWS and what we realized, what were our issues, challenges. For example, in one thing, it took us like weeks to figure something out, which at a conference, some friend of mine just told me, well, have you tried this? And it was actually it. So yes, this is what I'm going to talk about. First of all, you told you already set up stuff on AWS. Did you try to do it all by yourself, or do you use some tooling around it? So pretty much more of an automated way. Automated? Tooling? Someone doesn't know? Okay, first of all, what we did is we started with an automated way, specifically KUBE-UP. It's kind of an old shell script, which is just pulling the AWS API, trying to set things up. It comes up, but after some points, the cluster failed. Things went down, so we had the problem of actually trying to get this stuff back up working. Didn't really work well, specifically because we had custom registries and like people just manually added stuff on top of this automation. So we basically had the biggest challenge when the guy who actually set it up was on a tech conference in, I think, even Hamburg, and we just couldn't reach him. And it was my first day in the company, and we had no idea what to actually do. Just, yeah, well, you know, Kubernetes was pretty much the idea. So that was fun, which leads me to my first point. When thinking about this thing, people rarely document what they have been doing, especially when it's just small things like adding registries to the clusters. So in terms of automated versus manual, try to teach them to do it in an automated way. Give them Ansible, give them Puppet, just have them write bash scripts, Python, whatever you can think of. But if you ask them to actually do this in a documented or automated way, they don't really need to document that well, because you can replicate this with the scripts and you can get the information back out from the scripts. Especially Kubernetes can be quite a bitch. We've been trying to deploy this to Google Cloud once manually because of Google wasn't that scalable that time. And we realized how many shell scripts mixed with Go Kubernetes is in on the backside. So if you try to do it manually, yes, you can, but think about people rarely document that stuff, and you will face problems in the later stages of operating a cluster, actually. Leads me to the second point. Yes, manually works, but it works once. At some point, when stuff fails, you need to fix it, but it won't work on the next end if you try to fix it. Stuff will go back up. Yeah. Another easy way to do it, what we learned, is if you've done it manually, save it as an AMI, because then you can just kill it and boot it back up to the state it used to be. At least the configuration is preserved. So especially with Kubernetes, pods and everything can shift around the cluster. Pretty much the most important part of your cluster is the master, because of this tries to persist state. But any other slave can go up and down. This is pretty much the architecture of Kubernetes. So if you just save what you've been doing, for example, using AMIs, you can also use other toolings around this. Ansible is quite famous these days. Then you have the luxury of being able to actually like just rescale your cluster. It doesn't even have to go down, but you cannot rescale if you haven't automated it in a way, because of then the cluster won't talk to each other quite easily. Yes. Also, things to consider, dev clusters can be quite simple. So in this project, we had the idea that we can give every developer its own cluster to play around, to work with it, because of we can and because of it's cheaper than actually buying this stuff on premise. Also, Kubernetes wasn't working that well on developer machines that far, or at that point in time. So we realized, just give them a basic Kubernetes cluster they can play around, and using automated ways. This is as simple as triggering a job in Jenkins to actually set it up in the cloud environment, but also tearing it down is just a simple click. You do not want to go to your ops to actually set up a new cluster for every developer that is onboarded, and every single time the developer did something that is not functional anymore. Because especially if people do not know Kubernetes, they quite often do play around. They Google stuff, and this is not that compatible with Kubernetes at some times, because of also Kubernetes updates its source code quite often. So we will often face challenges if you cannot set it up again. If you think about how to design and set up your cluster, very important in terms of avoiding it works on my machine is production should only be sized differently. Do not try to use different Kubernetes configurations to make it more secure or something on production just because of it is production. If you start doing this, your developers will start, first of all, you will hear complaints that it worked on the dev cluster. Q&A will say it worked on the dev cluster, but it doesn't work on production. So it's pretty much up to the ops guy to fix it. And this situation is kind of toxic, especially if you're working in bigger corporations. The problems are that you have tested it in quite a few stages, and it was quite expensive to test this as well. So if you try to do production differently, you will also need to test it differently. If you just size production differently, you have the luxury of being able to just set it up in a bigger way, and you can just reroute traffic, for example. If you do it automated, this is quite simple, because if you just change some values, how many servers you want to deploy and what types of servers you want to deploy. If you do it manually, you often have the problem that you treat your service like sheep, like pets again, and they really start behaving like they shouldn't. But you cannot replicate this, so it's even tough to debug if you haven't automated it, because if you cannot see what's different right now. Next step is how to actually size your cluster. Best case, people want to performance tests. People will do performance tests. The bigger the corporation gets, the more they will do. And at some points, we realized, well, the application is quite performant, even on local. Our developers were super happy. They tested it, all good. But the problem is, as soon as we hit AWS, it started to get slower and slower, and we couldn't figure out what was going on. And at some point, we realized Kubernetes scheduled some of the bigger pods or the bigger Docker containers onto one node. And we had a, not even memory restraint, but the biggest restraint was networking. So the point is, you can use the biggest service you can have on AWS, but they do have capacities. So very important, also consider network capacity. Especially in these days where everything is kind of a microservice, network capacity will become your bottleneck. Like Java applications tend to get less famous, so there is not just one application eating all your memory, but there are like 200 applications eating up your bandwidth. Yes, servers do cost money, but please, Amazon offers different types. Pick the best that is suitable for you. Also, think of picking different servers for the same cluster. You do not need to do it all, for example, M4XL or something. Just pick the one that works best for you. You can configure how Kubernetes behaves with the scheduling. But if you think about those steps in advance, you do not need to reconfigure your cluster when it's running in production, and you realize you have performance issues. it works quite well figuring this out because of you can play around with it. We will speak about a tool in a bit, which allows you to just automatically do everything on AWS. So they start setting up your network, and they will continue to set up the server. And there you can just play around with the values and see how does my cluster behave if I size it differently. Yeah. Also, one availability zone on AWS is not fault tolerant. Who does know what an availability zone is, first of all? Just a few. Who does? Does, yeah. Quite a few. So basically on AWS, they have data centers. Really, they do. And they are in different locations. So meaning one availability zone is speaking Amazon is one data center. And one data center can go down. They even reserve the right to do maintenance work. So they just give you 99% uptime guarantee per availability zone. Meaning if you put your entire cluster into just one availability zone, it can go down at any point in time, and your entire cluster is lost until Amazon restarts the entire thing. Meaning if you distribute this across each regions, like the least is 2, most have 3. If you just schedule it across the board, across the data centers, you can combine the networks, so that's not a problem. But then you can really give this 100% uptime guarantee if you want to, or at least try to go to 99.999% or something. Because Amazon will not, because of they want to shut down your cluster, because of they need to do some network maintenance work in their clusters. Again, tools that help you to automatically deploy Kubernetes on AWS know this, and they have implemented features to actually even do this for you. But keep this in mind, they won't do it automatically. So you specifically have to tell them you want another node farm in the other region. And you also want another master in the other availability zone. Because if you don't do this, yeah, well, can be down at any point in time. The other advantage is they are physical data centers, but physical data centers have capacities as well. So you cannot just go there and say, I need 200 more servers. At some point, also Amazon will hit capacity, at least temporary. So if you span different availability zones, you have access to more capacity. Because if maybe in Frankfurt, even if the one data center is full, the other might have some service left. And then you can get more capacity you need to actually run your cluster. And Kubernetes will actually schedule the pods and the containers all around your cluster, so you do not need to care about where they're running. If the entire availability zone goes down, Kubernetes will shift them all to the other cluster or the other availability zone. But also, if you have capacity constraints on the one, Kubernetes will just run more on the other cluster. Yeah, think redundant is the word here. So important applications have to support this. So in some project we had they were using WebSockets, super fancy application. The only problem was you couldn't really run this in Kubernetes because if they just shut it down, all the connections are lost. So please do not just do this, especially if you're working in bigger projects with bigger corporations. They often have software that do not support this functionality. So find ways that actually work for both ends. Then permissions. Who of you is dealing with compliance in the company? Just a few. Okay. Interesting. So in our project, we have the problem there is compliance, namely the mother company Siemens. And they have compliance restraints for how to operate stuff in physical data centers. And now they realize, well, we need something for cloud as well. So we just take the same ones. Very good idea, if you ask me. They even have a team which evaluated all the services and what you need to do. Thank God now they're working with Amazon to actually do this one-click compliance tooling around this. But still, it is, they have rules what you need to do, and then you need to follow them, and then there is an audit and all that stuff. So what I can tell you is when you start deploying Kubernetes in cloud environments, first of all, use personalized accounts. Even if you don't use the root account, do not have one account for the team and just hand over the password or something. Please use personalized accounts. Amazon offers them for you for free. So just take them, use this functionality. Then especially compliance will make it way more easier for you, because of then you at least comply to some of the rules already. Because of they really have this idea of a data center, like you have your key, you get in. Yeah, if you have a personalized account, you have your key, you can get in as well. You can use federated services, so you can connect Active Directory if you want to. You don't need to. But yeah, personalized accounts make your life with compliance way more easy. Also, there's something called server roles. So Amazon pretty much gives the server its own identity, and Kubernetes can actually talk and use those identities. So for example, if you use the registry Amazon provides as a service, you do not need to take care or care about access permissions or anything, because of the server will authenticate itself against the registry and pull the data. So yes, if you facilitate server roles, you can just give the server certain permissions, and it totally doesn't matter who is triggering some stuff on the cluster, because of the cluster authenticates itself. And if someone breaks in and downloads your entire configuration and puts it on his server, it won't work again, because if the server doesn't have the credentials anymore. So server roles, in this case, make your life way more easy. If you get deeper into it, for example, if you have one account for your entire setup, you can use tags on the machines to actually control what permission what user has. So even if you do not have different AWS accounts, you can give all your developers access to the entire account, and then just use tags to say, well, you can only talk to the service you work with. Makes it way more easy to actually, yeah, work in environments where you just can't get another account because of someone in accounting is just doesn't want to, for example. Again, automate everything. So permission management on AWS, it's all JSON. And there are toolings, for example, for Python, it's called Troposphere, where you can just codify the entire setup. So especially permissions can be quite huge, especially if every developer needs its own set of permissions. If you do this and do this manually, I tried this once. I totally got lost where I was. So try to codify it. It makes life way more easy. Basically, what I always tell in cloud is success is when no admin ever accesses AWS, because of it's all scripted. Because of then you also do not need personalized user accounts. So yes, the more you automate, the easier it is for you in the end. Speaking about installation, we just said, well, if you have just one account, the alternative is if you have multi-accounts. But if you install multi-accounts, please take permissions into account. So there is a service called Amazon S3 for storage, and you can like give everyone or anyone access to this service. We did this to actually put the cluster configuration in for the tool, by the tool we use to actually set up the cluster. The only problem was, well, one account is easy. They help you to manage access. You can give your developers access, but it helps with centralized cluster management, Jenkins, Bamboo, you name it. But the problem is, in S3, even though it looks like there is no owner, the AWS account linked to the access credentials that actually created the object is internally referenced to as an owner. Meaning, as soon as we started to try to delete it or move it around from another account, we couldn't. Especially the Kubernetes tool we were using couldn't, because of some API endpoints were really picky on this owner flag on the actual object. So just doing something in S3 with KUBE-UP, no, KOPS in this case, can be quite tricky. So always think where to put the bucket first and then leave it there, because of you will need to invest lots of work to actually move the S3 bucket around, just to transfer this owner flag. You basically need to take a copy of the entire thing, become the owner of the files, and then move them around. Our problem was the account where we put this in was transferred to another unit. So yeah, we spent like a week to try to figure out how to get all the data out of the account, just because of it was quite tricky to actually extract it for those, yeah, kind of looking very small limitations Amazon AWS gives you. Yeah, of course you can also automate it, especially if you use multi-accounts, use Jenkins, use Bamboo, use tools you want to. We are quite happy with GitLab CI nowadays. So it really helps you control all the different accounts as well. Especially if you use Jenkins or Bamboo on AWS, you can use the server roles to access the other accounts as well. You can also use the server roles to access the AWS services directly. So you do not need to care about anything else anymore, because of it's all like authenticated on the server, not on your personal account. Other companies, I've seen it. Yeah, well, it just doesn't work anymore. Yeah, well, the colleague who left like 1 year ago, they just discovered his account wasn't deactivated in Active Directory. Now they did it, so basically 3 deployments just stopped working because of, yeah, the used to be deactivated for a year account now finally got deactivated. Speaking about tools, we started KUBE-UP. It works, so you can get your cluster up quite easily. The only problem is you cannot really customize. So KUBE-UP gives you a very specified cluster. You can work with it, you can test stuff out, but as soon as you come to updating, it's a pain, because if you really can't update your cluster with KUBE-UP. You can also not move it, you cannot make it bigger, you cannot make it smaller, you can just, yeah, well, try to duplicate the instances you already have. Also, if the cluster is deprecated, KUBE-UP won't help you recover it at all. It's just a shell script which really much talks to the Amazon AWS API and kicks something up. Then we discovered KOPS, which stands for Kubernetes Ops. It's like the newest cloud agnostic thing Kubernetes provides. We are very happy with it. So you just have like, yeah, you can write very long commands, you can write shorter ones. They control it all in YAML files on S3, and it allows you to really set up the entire thing. So you just say, I need a new cluster, and KOPS will set up the networking on AWS, they will set up the network interfaces, they will set up everything you need to get the entire cluster up and running. And you can specify how much nodes you want. If you want to be more controlling, you could say, but I have the network already, so please use those networks I have. Yeah, it controls it all. Very important, if you use KOPS standalone and just say, create me a cluster, it will just use, I think, 1/6 of the network it actually provides. Why? Because of KUBE-UP was meant to be compatible, but KUBE-UP reserved other parts of the network for its setup. So they said, instead of like trashing the other cluster as well, we just, well, block this out in our deployment and use the other parts of the networking. So you just get even if the subnet is like 200 IP addresses or something, KOPS will just give you like 10 maybe. So you really need to think about how you configure it in order to get the most out of your networks if you let it control the networks. Also speaking about networking, mind your IPs and VPCs. So yes, KOPS does create the network for you. It tries to keep it compatible, but also Kubernetes pretty much reserves IPs. So we just had one admin create a new VPC or network for databases, put the databases in there, got it all working. The only problem was our Docker containers were unable to actually communicate with the database. So after quite some time, we realized, yes, because of on the cluster, Kubernetes has IP tables rules which route those networks internally, because of they could be other pods in the network. There could be another service running on this IP, so they're all routed inside the cluster and they couldn't reach the database. So when you think about your networks, always keep in mind the subnet you're using for the cluster is entirely blocked for Kubernetes and it's all routed in the cluster. You cannot put databases in there. Also, if you use KOPS standalone, KOPS will always create the same network ranges. So you have like 5 different clusters with all the same internal IPs. So you cannot link them all to the same database VPC, for example, just because of then you would create this mismatch that you have like 20 or 5 times the same IP in your routing table, for example. Yeah, use different VPCs and network ranges. It helps you quite a lot. Especially it avoids lots of problems. Also, yes, consider shared resources and don't overlap your networks. Other questions to this so far? Especially setting up. Networking can be quite painful. Like we tried a lot and redid the entire cluster like quite a few times. Especially this networking thing with the databases, it was quite painful to figure out. Because if you just don't know where to find this or where to look, You set up a new instance, you go to your jump host on the cluster, connect, well, it's working, you wonder what's happening, what's going on, and then at some point you realize, well, this is just Kubernetes internal, and no one had the idea to actually go onto the specific host and try to connect and see what's going on. So yes, networking and Kubernetes on Google Cloud is way more easy, but there again, Google operates it for you. So Google figured this all out for you. On AWS, you need to figure this out all by yourself. Last slide's operations. So databases, some do put databases into containers. And yes, it is possible. You can do so. The only problem is it's not a good idea because first of all, updates are your responsibility. And yeah, updating is not the most favorable thing, especially when it comes to production and the databases in the container. Also, probably my biggest concern is state can be lost. Shutting off databases just from one to the other second is never a good idea. But if you have like a service, do it because it realizes the other instance has more capacity for the database. You pretty much try to destroy your own database just because of the software thought it was a good idea. So if you put the services into a container, at least do not try to operate this into Kubernetes because it will just shift it around all the time and will try to destroy your own setup. Best case, or my advice is always, AWS services are just too cheap to ignore them. So they're not like for free, but especially if you think about how much time you need to actually update this, configure this in the right way, you can just go to AWS and boot it up for like, I don't know, 30 euros a month and then just have your database up and running. And it is out of your control, but it just works pretty much. And it works in the cluster already. And you can make use of the AWS permission management they already provide as well. Logging. You can use the built-in Elasticsearch log/Kibana stack in Kubernetes, but I don't specifically like it because of persistence. So if the cluster goes down, for example, or you just have networking issues to the cluster in AWS, someone broke something in the VPC settings, you have a problem that you cannot get access to your logs to actually figure out what is going on. Especially Kubernetes, the user interface they provide to actually connect to this, it is all running in pods on the Kubernetes cluster. So if your cluster stops working, you have no way to figure out what was going on. Even the Elasticsearch, the built-in ELK stack office is running in Docker containers on Kubernetes. So even if just this Docker container goes down, all your logs are pretty much gone until you get it back up. So our preference was really attach it to the AWS Elasticsearch service, because then, first of all, the Elasticsearch is guaranteed to be up. We don't care about what's going on, how it's operated, but at least we get access to our logs all the time. Also, AWS Elasticsearch already brings a Kibana on top of it, so we don't even need to configure this. The only thing we did was provide a proxy with authentication in front of it, but that was pretty much all we needed to do. The only thing that really was some effort was go to GitHub, find a fluent deconfiguration that works with this, and actually deploy it as a daemon set into our cluster. But there was like, well, 30 minutes to figure out all the little details. But then again, we had a fully functional logging solution in a matter of minutes for our entire cluster. And even if the entire cluster is gone, or we just decide to delete it because if the developer doesn't need it anymore, all our logs are still in the externalized Elasticsearch cluster. So even if you decide to just let it go because it's just hopeless and you need the IPs, you can figure out what was going on in like looking back because it's somewhere different. And then my favorite story, custom registries. Is anyone using a custom registry? A few, yeah. Interesting. With Kubernetes? Yes. Cool, very good. So what we realized is the cluster was running for like a month, 2 months, and at some point we just got a very fun HTTP 2.0 error that the cluster was unable to pull new Docker containers. She knows. It's very lovely, and we had no idea what was going on. Like, the fun thing is if you just destroy the instance or just reboot it, it starts working again, and then after 2 months it's gone again, and you have no idea what's going on. It's nothing, nowhere in the logs. You have no idea what's going on. So we started rebooting the cluster on a daily basis, pretty much. But at some time at a conference, a friend told me, yeah, he had the same issue, and what happened is that at some points, latency, whatever, some timeout happens to occur to the registry. And Kubernetes doesn't automatically reconnect to the registry if this timeout occurred. So actually fixing this not being able to connect to the registry problem was going to our load balancer and tell him, well, your timeout is 900 seconds, which actually fixed our problem with the custom registry to actually be able to connect back to it. Also, in the first story, I told you, well, some people added them manually. You can do so, especially if you have no valid SSL certificates. But if you do this, you pretty much have a tough time figuring out how to do auto-scaling if you need to go to every single host and add this invalid registry or trusted registry manually first. Mind the timeout. And also think about permissions. So especially the default registry you deploy is just very, everyone can do it all. So either use an Nginx. We did this with, we even got a valid certificate because of Amazon with the certificate manager gives you free SSL certificates. We just put up a load balancer in front of our, one little node that's a proxy to S3 for the bucket, for the containers. And then we didn't even need to care about, invalid registries and all that stuff anymore because we just used a valid SSL certificate that we didn't even need to order ourselves. It was just, providing, clicking a link in an email telling, this is my domain, and adding it to the load balancer, which costs you 15 euros a month. But that's quite more easy than actually doing this by yourself. Also thinking about permissions, most people forget Kubernetes does talk AWS. So it's done by Google, but it does talk AWS. So if you use the built-in registry Amazon provides you, all the permission management and also all those timeout issues are taken care of for you. So Amazon has this service and Kubernetes does not just pull the image using the public channels, but use internal API endpoints by AWS to pull the Docker containers. This means you always have a more certainty that you're actually able to get all the containers in the way that you actually want them. Also, custom secrets are possible. So if you decide to do it by yourselves, if you have secrets, you need to provide them to Kubernetes. There's a command line interface command for this. But again, for every different namespace, you need to do this again. So what I learned is custom registries on Kubernetes. They work, but I think Artifactory or Nexus, SonarQube Nexus, or just using some stuff like Google provides or AWS provides is just the better solution because if you always have so small problems and you do not need to figure, or you have no idea how to figure them out because they're just so new and most people go with the standardized solutions, especially bigger companies just buy Artifactory and then it's really tough figuring out what is going on, especially because of all the people that really work with Kubernetes on a daily basis, for example. Like even Kelsey Hightower was like, well, I have no idea what's going on with this HTTP 2.0 error just because of, he uses the Google provided registries and this just never happened to those people. It's by design, pretty much. In the end, yes, you can do Kubernetes in all cloud environments. Specifically, KOPS is built to work with Azure, to work with Google Cloud, to work with Amazon AWS. I think it even works with on-prem. But this talk was just focused on AWS. So we can, I'd love to talk about other cloud providers, but this was my experiences doing this on AWS. One thing I always ask myself every day is, even as a developer, have I thought ops today? Just to make their life more easy and to be more certain my stuff will work on ops today, or will work. And then, do you have any questions? She told me she wants to run around the cinema, so.
Danke. For databases, did you ever try to run databases in Kubernetes with persistent data?
Yes, we tried. But at some point we realized, first of all, some people love this 3-layer approach, so they want the databases to be somewhat isolated. Also, running the databases in Kubernetes is painful because it can get scheduled around. So the endpoints might remain the same, but especially like persistent connections to that stuff always break. So I had one project where like it was down and we debugged what was happening for like almost like 1 hour until we realized the application is totally fine, but just the database is too small. And no one tells you that. And if it's in a container in Kubernetes, it's even tough to figure out the metrics for this. So I prefer to run databases like virtualized or really on the bone, or just use a service for it, just because of it's like database admins are there for a reason, and databases can behave quite differently in different environments. So like just putting them into a container works very well for developing stuff, but the developer just has one machine. There is no cluster where it's just shifted around all the time. So yes, I really like to not do databases in containers.
Thanks.
Other questions? Somewhere in the back? No. Yeah, it's definitely too early. That was my impression when I got this slot as well. Well, then thank you. Enjoy the rest of the day. Enjoy your hangover probably.